All right, we're still using the example where we have a job as a quality control engineer working at a German clock movement factory. And here's the situation. The boss, the president of the company, comes up to you and says, we'd like to put out a new advertising pamphlet. And in the pamphlet, we would like to say that 99% of all our clocks are within so many seconds after 24 hours. We know we have high quality clocks, and we'd actually like to state this in a brochure. But the boss is coming to you to know what we can say that would be the truth for the number of seconds. Now, and of course I mean by seconds of either fast or slow. Right, this has to be so many seconds being fast or slow. All right, so the question is, if we have a normal distribution, and in this case we've stated that it's going to be a standard normal distribution, if I account for 99% of all the clocks, and this is 0, all right, mu is 0, well, what is this as on the x-axis? What is this value and this value? Since it is symmetrical, I know that these values are going to be the same. Only this is positive and this is going to be negative. This is the fast side and this is the slow side. But the question is, what is this value that counts for 99%? Well, I know the empirical rule tells me that I have to go out 3 standard deviations to be at 99.7, but I want 99%. So it's going to be pretty close to 3 seconds out, but not exactly. I would like to know the exact answer. What can I put in here exactly? Okay, well, it's just a matter of using our table, but using it backwards. Instead of starting with an x value and coming up with the percent, we're starting with a percent, and we need to come up with the x value. So we're just going to use the table backwards. Okay, so we need to find the value 99% on our table within the actual content of the table. This is not a z-score that's going to be on the left side and across the top. This is a number that is within the content. So 99% is 0.99, but we know our table is accurate to 4 decimal places in the actual content of the values. So we're going to do 0.9900. That's what we're going to be using. Well, let's see if we can find that. 0.9900. Where in the world is that? I kind of have to look for it. Here's 0.9909, 9906. Let me see if I can pull this into where you're looking. 0.990. There's 0.9901. Now we don't have a 0.9900, but I'm pretty doggone close. There's 0.9901. Okay, there it is. Well, what is this percentages or this probability's z-score? Well, if we go across here, we see that it is 2.3 over here. And what column are we in? We're in the 0.03. So putting those together, I forgot what the first one was. 2.3, so it's going to be 2.33. So we're saying my corresponding z-score for this, z equals 2.33. So what does that mean? Well, since on a standard normal distribution, the z-score is the x value, then we can say right here. After looking at the table for 10 seconds, we'll tell our boss, you can say that 99% of all our clocks will be within 2.33, or 2 1/3 if you like, seconds after 24 hours. And your boss goes away happy, and you get a raise.